On behalf of the crowd.
Let's see. Waiting for comments to come through. We need one comment to get started to tell us that there's really an audience.
There are currently, the teaspoon's here.
The winner of the most alt.net,
Yes.
I think.
Very nice.
Oh, beautiful. Okay, I think we've got an audience. We can get started. So, like I said, welcome. And today we've got Anton and Richard here. So Anton's going to talk about GraphQL in .NET, and Richard's going to talk about .NET 5. So that should be exciting, the new hotness and some interesting stuff in the GraphQL space. Let's see. Hi, everyone.
You're so hot, .NET.
So as usual,
sorry, I'm a little lucid. Not necessarily lucid today.
save it for the second presentation. So yes, the other thing is we've got the competition as usual. I don't know if Lord Teaspoon can win yet another prize, but it's possible. The lucid most days, just not for .NET. Yeah. So in terms of the prizes, it's a JetBrains license. I'll write down 2 questions during it, and then I'll ask you at the end. And the first one's
going to be related to the talks, right? They're not just 2 questions, like random stuff.
Correct. No spelling questions, no maths questions. They'll all be
not like what's the speed limit outside your house, nothing like that.
No, we make it a bit easier than that. It's really about one from each talk to give you a hint. All right. So do we want to say anything else, or shall we go to Anton?
Let's go to Anton.
All right. Okay, let's do it. You ready, Anton?
Yeah, let's do it.
Okay. All right, you're on, Anton.
Cool. Can you see my screen?
Of course.
Awesome. Okay. Thanks, guys. Today, I'll be talking about implementing Apollo Federation with GraphQL.net. So before I start, a little bit about myself. I'm a software engineer as a background. I code monkey until today. I started my career in financial services, and in 2018, I joined Woolies X, where I'm currently a platform engineer. And this is just a list of technologies that I use day to day. The most relevant one for this talk will be GraphQL and .NET. And just some social links, just if you want to reach out. Not super active on Twitter, but it's there. I'll keep an eye on it over the next couple of days. So what I want to talk about today, what the kind of flow will be, is I want to give a brief intro into GraphQL, not too much, because I think we've already had a presentation on GraphQL. So it's kind of taking that to the next level, which is seeing what architectures are commonly found in the wild and different pros and cons of each approach. And then what we'll do is we'll see what the experts have to say in terms of best practices, and we'll have a look at one of the technologies that came out of those discussions, which is the Apollo Federation. And then we'll do a demo that kind of showcases what's possible and how we build those services with .NET to kind of bring it back to the .NET world. Okay, so just briefly, GraphQL. So it's a query language for your APIs, and it's a runtime for fulfilling those queries. It was initially developed by Facebook internally, but has since become open source. And it's become a spec essentially for developing web APIs. And it's very similar in concept to saying REST, gRPC, and what are other web service architectures. Due to the fact of it being open source and being a spec, we can get implementations in Node, .NET, and all the kind of popular languages. Today, we'll be working with .NET and also a little bit with Node.js. And how does it work at a high level? We use a type schema to define our data. So hopefully you can see my cursor, the first screenshot up the top. We're defining a type called project, and that type has just some fields on there. And that can get more and more complicated, so you can have nested types, arrays, etc. Then you need to write resolvers, which actually fetch the data. It basically tells GraphQL, okay, if somebody's asking for a project.tagline, how do I bring that data back? And that's usually where you tie it with your repository or your data service. And what GraphQL will do is, depending on what you request, you get exactly what you asked for back, nothing more and nothing less. So it's really good if you're doing like a BFF, or if you want to have like a flexible querying language on your API. And the GraphQL framework knows how to kind of parse the query and resolve only what's required to fulfill that query. It's not tied to any specific database or storage engine. So the way I kind of think about it, it's like a presentation layer for your API. So where you might be familiar with the REST API, it's just getting rid of the controllers and putting a GraphQL resolver on top. What's out of scope for this talk is GraphQL mutations and subscriptions. So we'll just be talking about queries. Okay, so what are the common architectures we see? So the first one is really basic. It's a GraphQL server with a connected database. And it's very similar to just having a standalone REST API backing onto a database. And this is really simple because it's one schema to be aware of. So one GraphQL schema and one endpoint that you can query. The next step from there is having multiple of these standalone services. So this might be something that you might now have at your organization with REST APIs. So you'll have multiple microservices all over the place with a API. The problem with this approach is that due to the distributed nature, I guess, the discoverability is a bit low. So it might be difficult to find where all those endpoints are, what the types are available, etc. You have to integrate with multiple services, so a lot of repetitive work that's required there. And what you see as well is you'll start seeing some duplication of fields and types. So if you have like some really popular types at Woolies, for example, it's an order. So you'll find order split across like all the microservices. So you'll definitely have some duplication there for sure. So the next kind of evolution beyond that is using GraphQL as a kind of gateway. So you can have all these backend systems, microservices, RESTful APIs, legacy systems, and what we do with GraphQL in this scenario is we basically use it as a gateway to kind of bring together all those services. And we have one query endpoint and one schema. It's equivalent to an API gateway in a sense. It could replace the need for BFFs, so backend for front ends, because you can, instead of having to implement specific gateways for a mobile app or a desktop app, sorry, a web app, the response kind of becomes dynamic based on the query that you send through. It can also act as an anti-corruption layer. So you can define your ideal schema at the GraphQL server and kind of hide the nastiness that's going on behind the scenes. All the stitching logic, like once you've told GraphQL how to resolve based on these backend systems, GraphQL knows how to do the stitching and distributing the requests across the three services in this case. So you don't have to write too much gateway code. It's more just getting the data, and GraphQL will put that together for you. But the downside of this approach is as these backend systems grow in number, this GraphQL gateway in the middle will become quite large and monolithic, and you'll have a lot of people, creating PRs there, conflicts, etc. So that has the opportunity of becoming really nasty as it evolves. And finally, there's the hybrid approach, which is essentially having the GraphQL server being its own kind of standalone service, as well as acting as a gateway, and it's got the same pros and cons as the architecture above. So what do the experts suggest we do? So Apollo from ApolloGraphQL.com, they've been building data graph tech for many years, and their GraphQL software is really popular. So what they wanted to kind of do is compile a set of best practices for creating, maintaining, and operating a data graph. So they came up with the 10 principles that you can see on the side there. Hopefully you can see that. And they put it together. They called it Principled GraphQL. It's kind of separated into 3 main areas. And we'll be touching on the first 2 principles in this talk, which are one graph and federated implementation. And these principles are essentially distilled from thousands of conversations they've had with developers of GraphQL at a company of all sizes. So what are these principles that we're going to be referring to today? So it's the one graph. So what the one graph says is that the company should have one unified graph instead of multiple graphs that are kind of spread all over the place. So if we kind of jump back, we don't want this second case here. We would like to have a single graph to integrate with. So by doing that, more of our services are accessible with a single query. There's a central catalog of all the data that the graph, there's a central catalog of all the data that's available for the users. The implementation cost is minimized because we are integrating with a single endpoint. And again, because of the central management of that one graph, you can do things like unified access control policy, etc. The second integrity principle is the federated implementation. So while they're promoting having a single endpoint, a single gateway to integrate with, they want to avoid the problem that comes with that monolithic architecture that we discussed earlier. So these 2 here. So we don't want to have the monolithic nature of this GraphQL server. So they proposed a federated implementation. And what that means is that you can split up your implementation across multiple implementing services, and then GraphQL will bring that together and present it as a single interface. But what they do is they use a declarative programming model. So you actually define the schema at the implementing service level, and you don't have to do anything at all pretty much at the gateway level. So just to kind of help visualize that, and to kind of discuss the solution that they've come up with is Apollo Federation. So Apollo Federation is an additional spec. It sits on top of GraphQL, and it defines a few additional entities and fields and types, etc. We'll see those in the demo. And it enables us to divide the graph implementation across multiple composable services, which kind of ties back to the first 2 principles. The use of a declarative programming model means that we don't have to do any schema stitching or any complicated logic at the gateway. And it allows us to have each API to implement only its part of the graph that it's responsible for. So that's principle 2, having that kind of separation of implementation. So the architecture it consists of these multiple implementing services that we can see at this level. And then we have a gateway that composes those distinct schemas into a federated unified graph. And it also is responsible for executing the queries across these services. Something else that comes out of using federation, which really resonates with me, is when it comes to separation of concerns. So I'm sure a lot of you have seen services being broken up by type. So you would have a user service, a product service, and a review service. And if you go down that approach, what ends up happening is you start getting concerns kind of bleeding from one API to another, because a user can be defined in multiple services, similar to product and review. So in this first example, in this first row here, we have 3 services and they're kind of split by type. But if you look at the user, there's a user.name, but there's also user reviews, so the reviews that they might have placed for a particular product, as well as their recent purchases. So whoever's building the API for this service needs to kind of know about reviews and products. So it kind of has that bleeding effect from the other domains of products and review, and we'll start getting some duplication as well. And that kind of carries through to the other 2 services. So product has a reference to reviews, and review has a reference to user, etc. So with Apollo Federation, and we'll see how to do this in the demo, we can extend existing types and reference external types. And what that allows us to do is to split our services by concern. So the user service in this case only has the name information, and it doesn't need to know anything else. The product service defines the product type, and then it knows that a user type exists somewhere else, doesn't know anything about the fields that are kind of on that type, but it knows that it's going to extend that type by appending a recent purchases field. And similarly, review defines the base review type, and it extends both the user and the product types to append a reviews array. And what will happen at the gateway level is that these schemas will be combined into one unified schema that kind of allows you to query across all 3 rather nicely. So we'll go through a demo and kind of show what we're trying to do here. But before I do, are there any questions so far? Is it kind of making sense?
There was one. Fernando was asking, is it possible to scale that word? Scale is a word. I can say that. Is it possible to scale at the GraphQL layer easily like web APIs?
Is it easy to scale? Sorry.
Yeah, like a web API. So I think it's hard to know, but maybe consider it like a web farm kind of scenario.
In terms of having multiple instances, for example, of the gateway? Yeah, definitely. So what we've done in the past is the gateway application, it is an application, and we've Dockerized it and deployed it to Kubernetes, and we have multiple instances running, and there's no problem at all. So in terms of scaling that way, it's definitely possible. And similarly, each underlying application is deployed separately and Dockerized in multiple instances running. And depending on the queries that are being executed at the gateway as well, some services might be more popular than others, so they can kind of independently scale as well. So if this first service was really popular, there might be, I don't know, 10 instances spinning up, where the other ones are kind of idling at 2. So we've seen that kind of setup. Hopefully that answers the question.
Cool. And then there's a few others, though it looks like they're being answered somewhat in chat as well at the same time, which is cool. But how's it compare to gRPC, and can you do streaming APIs or streaming queries? Yeah, so I haven't tried doing the stream. So you can kind of do streaming with where is it? Subscriptions, which kind of similar. So you can kind of asynchronously receive partial responses to the query that you've made. I don't think it's possible to do that with GraphQL in a federated context. You can do something similar if you have just like a single GraphQL service. But I'm not sure for in terms of federation. How does it compare to gRPC? I find it a little bit more flexible. I think with the what's the schema that we use for gRPC is escaping me right now. It's a bit more I don't know if statically typed is the correct word, but it's a little bit more dynamic with GraphQL. But yeah, you don't need to, from a consuming point of view, it's a little bit easier because you don't need to know, you don't need to have those
types compiled.
I won't jump in to say protobuf is the answer to the question, but just so everyone knows, this is not the question for the prize.
Okay, cool. So if there's nothing else, maybe we can try and jump into the demo. Okay. I hope somebody's made a sacrifice to the gods of the demos. Righto. So is that visible? Can we see the three?
Yep, it's good. Very good.
Cool. So what the demo is, we're trying to kind of show that concept where we have these three standalone GraphQL services. And what we have is we have a Movie Studio API. So sorry, the example is pretty contrived. It's a Movie Studio API, which has the base movie type, and it has things like ID, title, when it was released, genres, directed by, etc. And these last three fields kind of reference a nested type of person that has an ID, a name, and a date of birth. Then we have the Movie Theater API. So this is kind of responsible for movie session times. So it's pretty basic. It just defines a session type, time, which theater is showing, and which movie. And finally, we have the review service, which kind of acts like, if you can imagine, like a review aggregator. So given a particular movie, it can bring back the reviews for that movie. So just a little bit of navigation around what the syntax means for anyone that's unfamiliar. We always need kind of this a type of query which acts as the entry point into our GraphQL service. So this first service defines a movie query, which you give it an ID and it brings you back movie details. The second one just has a single query for what's the next session, so really basic. And the final one has the ability to get a review by an ID and also get all the reviews for a particular movie. Now, all three of these services have been implemented with GraphQL.net. Before I kind of show the code for wiring it up, let's kind of see how things are getting deployed. So we've got these three services here. These are the GraphQL APIs and the gateway application here. So all the .NET implementations are kind of very similar, and we've Dockerized them, using multi-stage builds, and the gateway as well. So the gateway is implemented using the Apollo Gateway NPM. So it's essentially a node application. It's an Apollo Gateway. The way it works is you just give it a service list which points to each of your underlying services, and then we're just adding some middleware that will help us to visualize the schema. So at the gateway level, this is all we need to do. We just need to say, here's where the underlying services are, and there's absolutely no code in terms of how to bring that data back, stitch it, and route it, etc. And now to help me kind of start everything up, I've defined a Docker Compose file, and let's start it up and see what we get. Docker Compose starts. So I'll just start slowly. So I've just started up the Movie Studio API. So I've mapped the 4100 port so I can access it directly. So let's go and hit that endpoint and see what we get. So all my services have this Voyager middleware included, which kind of helps us visualize the types. So this is the movie query that we defined and the different types, so the movie and the person. And these additional fields here are included from the Federation spec. So we can kind of ignore that. That's being added automatically by the framework. So then if we go to the this endpoint here, so this is an ID that will help us basically execute queries. So we can see the schema again on this side. So let's quickly write a query. So cast and directed by, as well as written by, they're all person types. So I'm just going to reuse.
And you can make that a little bigger if it's easy.
How's that?
Thanks. That looks really good.
Cool. So I just wrote a query here and ran it and got back some movie information for Batman. And the cast and directed by and written by, if I comment anything out, I get back just the data that I requested. Okay, so that's the Movie Studio API. So let's bring up the other two as well. So Movie Studio, Movie Theater, and movie reviews. So we can see three containers running. Okay, so our movie studio, our movie theater with the next session query, and the movie reviews service with the review information. So if I again jump into the query editor for this, so if I go to Playgrounds, oops, I'm going to type that correctly. So we'll start seeing the problem here now when we have these separated implementations. So contains spoilers. So what we got back in this case is a list of reviews. So we can see the ID, we can see the movie ID. Oops. So movie ID. But we don't have any other information about the movie. So there's no, we don't get all that rich information that we were getting before. And that's because the rest of the movie fields are defined in a different service. And similarly for this one, 4,300, I believe. That's the one I just did. So this one only has the next session available, so which theater and what time, and in terms of which movie it is, we have no idea. It's just the movie ID. Cool. So because we're using GraphQL Federation, however, what we can do is now spin up the gateway and hit that endpoint, and we'll see something, hopefully magic, happen. Cool. Yep, so the gateway is running. The gateway is running on port 4000, and just to remind you, this is where the service list is configured, and it knows how to hit the endpoint thanks to Docker Compose magic. So it's being referred to by name here. And if we go to port 4000, so we'll see all that kind of noise around the federated types have disappeared. And now our query has a combination of all the individual queries that we defined at each underlying service. Our movie has the base fields that we defined, but now it also has reviews attached to it because we extended the type in the reviews service. So I'll show that quickly. So in the review schema, we said we want to extend the type movie and append a collection of reviews. So that's why that field is coming up. And now if we jump to the editor, maybe I can copy this one here. But now what we have is access to all the other fields as well. We've got title, genres, released, cast, name. Let's prettify that. So we've got that information. So the top level is coming from the movie theater API. Then the title, genres, released, etc. is coming from the movie studio API. And now we also have access to the reviews. And we can say stars and message. And is there anything else relevant? Does it contain spoilers? So we have basically combined all these separate schemas into one unified graph that's queryable from a single endpoint, and we didn't have to write any code at the gateway level. To kind of show what's going on as well, this editor has, it shows you the query plan that took place. So it basically gets the next session information from the movie theater and which fields it's getting. And then in parallel, because they're kind of independent, it goes to the movie studio to get the movie fields, and also in parallel it gets the review information, flattens it all together. So it does all this stuff for you, and it's really quite magical. And I love it when it works. So I might leave it at that. Let's have a quick look at how one of these services is being implemented. So it's very similar to a web API, a REST API that you might be used to. So let's jump into the program CS file. So pretty basic stuff, create the host, point it to a startup. So in our startup, we're getting rid of all the kind of traditional middleware that we have for web APIs, and we're adding the GraphQL ones. So these are all coming from GraphQL.net. And then registering our resolvers up here. So what's a resolver? It's equivalent to kind of a controller with actions in the REST API world. So if we have a look at one of them. How are we going with time?
Give it a few minutes.
So this is the top level resolver for reviews. So it kind of looks like a controller. So this would be your kind of routes. So for us, it's query, and then each one of these is the action. It knows how to route the request into these resolvers, and I'm just using Mediator to basically go and fetch that data. So the way it wires everything up is that the shape of the data that's being returned just needs to match the schema that you've defined in your service. So in my case, what's being returned by this resolver here, this review, should match what's defined in my schema here. Okay, I'll leave the demo to there. I think we covered a lot, so probably everyone's head is spinning. So we can just jump straight into Q&A or move on to something else.
All right, crew, ask questions. There we go. Does the schema have a separate date time, or is it a date type, or is it only date time?
So you can define whatever types you want. The ones that I've used are the ones that come out of the box with the GraphQL.NET implementation. So it defines things like Boolean, date time, all the kind of .NET types that we're used to. But there's nothing stopping you from implementing your own basic types. There's a proper term for that, but it's escaping me right now.
Cool. I'm just waiting to see if any more flow through. Can Apollo federate REST services?
Yes.
Which I think Andrew asked before, but we missed in the flow of other side conversations that were happening.
Yep. So I thought if we had time, we can go over this. But what you could do there is have a sort of migration strategy. So if you do have a REST API, you can't federate directly into the Apollo gateway. You need to intercept it with a GraphQL server that supports federation. So something like this, if that makes sense. And even if you have existing GraphQL services that don't implement the federation spec, you can do something similar. So you can have this kind of layer here, the stitching gateway that acts as the intermediary. And as you bring in new services into your graph, so this service F is a federated service, and then the rest of them are kind of being hidden away behind the stitching gateway. And as you kind of strip it out and start implementing the federated schema, you can take them out from behind the stitching gateway and have it stand alone to the side. So hopefully that answers that.
James, do you want to ask the question you asked?
I wasn't sure because I've got my kids in the background.
Oh, right. Oh, you want me to ask before you to cut out the background noise?
Yeah, so I was just wondering how much time it takes with in terms of the overhead of having the gateway there on top of the services, like I suppose, you know, proportionally or milliseconds or something like that.
Yeah, the testing we've done, because everything's kind of sitting in the same VNet usually, so it's all our own infrastructure, it's pretty low. So I think it'll just be, in terms of latency, is whatever's expected from just any type of gateway, I guess. What we found was the problem initially is giving the gateway container enough resources to run. That was the kind of bottleneck we saw, where the number of requests being handled was getting throttled, and then we just had to find this magic number of like memory and CPU resourcing that allowed it to kind of then handle a large number of requests.
Cool. All right, let's ask two more, and then we might switch just because of time. First one, is it just JSON and text or / text based, or can you do binary protocols as well?
It looks like JSON. It's their own kind of. Oh, you mean the response? Yeah. So, as far as I've seen, it's just JSON, at least out of the box. But it's a pretty rich ecosystem. So there's heaps of tools, and there might be something that allows you to do binary.
Okay, and then the last one, best practices around securing the endpoints.
The approach that we're kind of following is we're using JWTs. So we have an identity provider. Our client will authenticate against that and then pass the JWT while making a request at the gateway. And then at the gateway level, you can configure exactly how things, like you can intercept the route that goes to each service and, you know, enrich the request with additional headers or just pass through JWTs. In our approach, we're just passing down the JWTs to the underlying services. and then the underlying services are responsible for verifying the JWT and doing access control.
Awesome. And then there's probably only one more, which is completely unrelated, but everyone heard the mechanical keyboard going berserk. So I want to know what you've got.
Sorry.
Sorry. So this is the only mechanical keyboard I've got floating around at the moment, but it's not quite the same.
Yeah, I probably should have done it on my Mac and had the headphones on.
Oh, that's great.
To hear
awesome.
It,
We love old school. Make sure you keep the house awake when you're banging away on the keyboard at 1 in the morning.
That's it.
If you're going to work, make sure everyone knows about it. That's the approach.
That's right. Absolutely right.
Yeah.
Cool. Thanks, guys.
All right.
All right. Thank you very much, Anton. That was quite informative and definitely took our GraphQL to the next level on our previous intro talk.
Oh, is there a sample code base? Is that sitting around on GitHub or something?
Yep. So if you go to my GitHub, I'll add that to the StreamYard. Maybe you can share that.
Yep. Perfect.
Yeah.
That's good. All right, we'll pop it in the chat when it comes through. Yeah, maybe just email it through to me, Anton, if I can't see the chat message. Cool. Okay. So I shall switch us over to Richard now, who's going to tell us about the new .NET hotness.
The new hotness. And if you thought there was heckling going on before, it just went all the way up to 11 at this point, right? So what I thought I'd do just for this talk is with .NET Conf coming up and .NET 5 just around the corner coming up, basically trying to take all the noise and oxygen away from the console launches that are happening. Thank you, Aaron. Yes, I am allowed to code again, but only in the privacy of my own home. No, that's a chicken, like winner chicken dinner. Gee. And then a moth just decided to fly into the camera. So it's all happening here all of a sudden. I thought I'd run through basically the quick overview of what the intent was behind .NET 5, what the promise was, what we actually got, and then talk through anything else that's coming up that might be of interest. And then as we're going, really just hit on some of the things that you as a dev might be interested in. What are the things that we kind of need to know, not just all the detail we can think of for ourselves, but everything in general. So May 6, 2019, .NET 5 was announced or previewed, and the promise at that point in time was pretty straightforward. There was going to be one framework, one runtime. .NET Core, the framework for, the 4.x framework, Xamarin, Mono, we're bringing it all together, and Microsoft was going to create this .NET 5 launch, and it was going to be super exciting, and we were going to love the universe, and we're going to be all holding hands and dancing in circles. And they were going to be combining the CLR from .NET with the ahead of time compilation stuff from Mono for creating native exes, and that was the plan. And then things kind of went quiet for a while. Yes, new web forms, it'd be best, super best. Then coming in March 16th, 2020, we had extra promises. So this was around the time of the Build conference. And again, that idea of the unified .NET SDK was talked about, including the promise of being able to go .NET new Xamarin Forms and get a new project running on the full framework for doing mobile applications. We're going to have that single device for desktop, Android, iOS, web applications with WebAssembly supporting all the different browsers, mobile, native desktop, cloud native support, really small microservices, faster base container, base class library containers, better container support, even HTTP3 support. Who's heard of that, by the way? It's the protocol running on Quick. Yeah, it is a lot of promises, Francis, a lot of promises. So what are we actually getting? Well, we're not getting that because that's been pushed off to .NET 6 and MAUI. So all that Xamarin side of things, I went, yeah, we might have overpromised and underdelivered. So that's going off to .NET 6, which will be this time next year. So, mark that down in your calendar. We also, unfortunately, the WebAssembly thing isn't really there. Nothing new from Microsoft then, yes. This is going to be a short talk. Experimental Blazor bindings do exist for mobile, but pretty much at the moment, WebAssembly is browser only at this point in terms of what's working. Cloud native support, single executables, single deployment, single runtime, that's there, which is good. Small microservices are possible. HTTP 3, yeah, that didn't happen either, partly because most browsers still don't support it. Safari 14 does. You can enable it with browser flags in a few other places. And it is available as an experimental option. There's that number there is the GitHub number. So if you jump into the .NET project on GitHub and have a look at that particular issue number, you'll find a reference to it. That said, yes, lots of redacts. Part of the fun. The intent here is not to say .NET 5 is horrible, but that it's got a lot coming. They probably overpromised, yes, but there's still a lot of stuff in there. So let's run through it and actually have a look at what's of use. So core framework to start off with. Unsurprisingly, lots of work in terms of performance. The GC and the JIT have continued to get better and better and better. And one of the things they've done is move more and more code into managed classes and managed code, which means less unsafe calls, which means less getting stuck with the GC while it's waiting for native threads to finish before it can clean things up. The benefit of that is that less GC time means your application just runs faster in general, which is good. So no of those pauses happening. Additionally, the RIOJIT improvements means that there's certain scenarios it's able to optimize to generate less instructions, and unsurprisingly, less instructions means faster code. As an example, one of the key ones is white space was tweaked to produce less code. And because that sits underneath a whole lot of stuff in terms of string manipulation, which effectively is pretty much all server-side web, that leads to a whole lot of performance improvements just across the board. And as Teaspoon said, the quick side of things, HTTP 3, we'll have to wait and see. There's some stuff floating around. It's worth experimenting if you want. Not in this at the moment. A few key things that they talked about. There's been blog posts talking about .NET performance improvements coming up. So in32 two-string is now even faster, again, partly because of that that character stuff improvement under the hood. Regex improvements have massively increased in performance. If you like pain, hands up if you like regexes. Mutable list had improvements. System text JSON continues to get better. They've added extra performance related methods into the base class library. Mr. Teaspoon, we kind of need an intervention if you like your regexes that much. But the new methods, decimal now dealing with spans, sorts those things out, helps with improvements there. Memory extensions.sort has turned up, which is internally used in array and link. So sorting has become a lot faster and a lot cheaper, which is great. Always good to see that. And optimizations like string.split, if you put in this thing called trim entries, when you do your splits and you realize you're trimming down things, if the method will basically remove all the empties. Any of those items in the collection that would have ended up becoming an empty thing, it just removes it. So there's no allocations. And again, less allocations, faster runtime, less GC pressure, all those things, they're all good benefits and they all add up over time. There's also new performance analyzers coming in Roslyn. So as you start doing some of these things, it'll pick up things like that example there, where we're doing string.append and we were doing int32.two string because we just weren't paying attention. It'll pick that up and go, you know what, you're kind of being a bit of a dumbass because you don't need to go and do toString first before you go and append it to string builder. So, hey, don't do that. And that will generally result in, 30% faster code, which is always good. There was a blog post not too long ago about these things. Just look it up, performance improvements in .NET 5, which ran through a whole bunch of different scenarios. Some of the more interesting ones, as you can see here: string sorting, int sorting, covariant checks, trims, regexes. There you go. Look at that, 80% improvement. Doing a sum on an immutable list, massive improvements. All these things all add up to performance gains. And if you're thinking about how does your code run in high compute density in containers, then all of these things are really good. Definitely worth paying attention to. And I think in terms of just straight up moving from where code is today on, hopefully .NET 3.x to 5, just that performance difference there overall will make a huge benefit for everyone. And yes, value task pooling as well, Andrew's pointed out, is a thing in there as well. Definitely worth having a look at too. Another thing from a deployment perspective is we've got not quite tree shaking. I don't know what to call it. Maybe we should call it app trimming like Microsoft does. But if the compiler in the 3 series could go through and basically detect that you weren't using some of the assemblies you were referencing and drop them out. In 5, you can now go through and detect unused methods and rip the code related to that out as well, which is really nice. There's a blog post there, app trimming in .NET 5, which talks through one of the examples with .NET New Console, how that's done, and how you can drop that to a 10K assembly. But with member trimming, you can drop that down to a 2K exe, which is fantastic. And this is how we can get those less than 50K assemblies for microservices. So if you've got something that's doing, fairly specific things, have a look at how you do this app trimming. Also helpful for function apps, for example. Obviously, your benefits aren't likely to be as effective as .NET New Console, because that can be heavily optimized, since it does about, Hello World does about 3 lines of code, but it is still really good. One of the things to be aware of with this is that reflection makes this a little bit harder, because you've got to be able to, reflection being dynamic, it's hard for the compiler to tell what's being used. You can provide hints to it so that you can give it some guidance on what's being looked at and so forth. But the other thing to think about is that source generators, which we talked about in a previous alt.NET meetup in August, by default, source generators are reflection at compile time to a large extent. So we can reduce our use of reflection through source generators, which then makes the compiler more able to understand how everything's connected and then optimize again for that method trimming. So it's really useful. SUDS, is .NET 5 going to be an LTS release? No, that's the even numbers. So .NET 6 is the next one. Nullable reference types as well. Was a C#8 feature that had very, very limited adoption. Now the teams have gone through and really added nullable reference types to pretty much most of their code base, especially in the core and especially in ASP.NET. EF core is a little bit patchy because I had to wait for some link things to catch up, so it's not quite there at the moment. But if you're not doing a whole lot of EF, or you can isolate that to a certain part of your code, then you should be able to put on nullable checks through the compiler right from the start, and maybe look at doing nullable disable in the specific scenarios, and really drive down those number of cases where we've got the null reference errors and push that out of the code base, which is going to be a really good benefit. And hopefully we start seeing this happening in especially a lot of the NuGet packages we depend on. And I don't know if you've published any of your own, but if you have, maybe look at building that in so that people who depend on your package can start really taking advantage of that as well. So what do you need to know as a developer? It's faster. And that pretty much should be enough reason to do it yourself. You do need to target a new framework version. It is just .NET 5.0. There is no .NET Core app or anything like that from 5.0 onwards. You will need to move your old 4.x projects. Now that WinForms is in there, yay for WinForms. There really is no reason not to move your older desktop applications across, unless you're doing WinRT. But even still, you can do that. It's just not built into the framework. So you have to do WinRT separately. If anyone actually has any. Anyone? No? Crickets. I thought so. And move your code to C#9. We covered C#9 a little bit ago as well. Records and init properties will save you so much code. It makes it so much easier to understand. EF Core handles records just fine. ASP.NET handles records just fine. So go nuts. Start ripping out all your POCOs and turn them into one line of code. There are a few little breaking changes. Sort of, you know, the remoting APIs and global assembly cache. Who remembers that fun? They're now obsoleted. They're not broken. They're just obsolete. So you'll get warnings. Same with code access security APIs. If you hit it, thread.abort, strangely enough, is in there. And some binary formatters have been obsoleted because basically they're security holes and they can't patch them. So it's much easier just to go, yeah, don't do that anymore, and go and use JSON and XML serializers instead. And there's a few other things with WPF and WinForms if you're interested. All right, so that's the main framework. There are a few other things just in terms of the ecosystem that are probably worth noting. You can, if you wanted to play with it yourself, go and build the whole thing with a single line of code. So you can grab the whole framework, build it locally, do contributions, help the team out. Nice and easy. And there's also a new tool called .NET Monitor that's turned up. For getting into the instrumentation, understanding what's going on inside your application. Now, the nice thing with that is it exposes a HTTP API, as you can see, which means you can send requests to a container if you expose it, maybe to an internal side network. And say, get me the stats on what's running. Let me see what's happening in terms of memory footprint and everything else on production, and see what's going on, which is really nice. iDispatch got obsoleted as well, if anyone remembers what it is. I don't know, it's an interface, right? Let's have a run through of web stuff, ASP.NET Core. What else is happening here? Not too much. They talked about performance, and obviously .NET 5 helps with performance. They've got reduced allocations, but really there's not much going on. Endpoint routing was in 3.x, which is basically the ASP.NET Core's team's approach of doing Nancy. That's kind of the code that you would see there, which is all nice. And if you haven't used it yourself, it's actually good for small APIs. They've added a few extensions for making things with HTTP context a little easier around the JSON side of things. So these are kind of health little improvements just to make stuff a little simpler. So if your old code was doing that, you can now replace it with one line of code instead of two. Okay. Not much going on. A lot of what they're doing, you'll see in a second. There's a few other things that are happening there. AAD authentication's moved out. So if you're doing that, just be aware you probably want to move to that identity.web library now. .NET Watch has been changed so it can auto refresh, which is kind of nice. Not quite hot module reloading, but still nice to have the browser auto refresh for you. So as you're making changes, you can see things happening. JSON console logger is now available. So they made the console logger extensible, and there's a JSON one there, so you can get structured logging happening if you're interested. And there's a new API template. The new project template includes OpenAPI enabled by default. So if you don't want that and you do spin up a lot of new projects, you'll have to go and turn it off. Not the end of the world. Where's the team been investing their efforts then? There is really only one answer if you've been paying any attention at all, and that is Blazor. So .NET New, Blazor, WebAssembly will go and do stuff. I'm not going to cover Blazor at the moment. There's too much to it. There's heaps. There are a few other little things. Yet another reverse proxy as an experiment has been made available. gRPC Web as well, if you're interested, which is basically gRPC over the web. Don't know how they come up with these names. But again, coming back to performance again, as you can tell, this is somewhat of a theme. Performance was really good with .NET Core in 3.1. Really, really nice. You know, that's what you're looking at there is the mental blank. Don't help me, anyone. The performance benchmarking thing. wow, I so have had my brain just fall out of my head. Someone can comment on it, but basically it was doing great. 1.3 million requests per second, much better than Spring by a long shot. Yes, Tech Empower, thanks, Suds. Thank you. ActiveX was number 2. No. Express for the Node fans, sitting way down there, and for James in particular, who loves his Rails, it's in the top 100. That's nice. And that was in 3.1. They've got internal Power BI reports that they make available on the web in terms of where things are at. Here's the 5 numbers. This is kind of scary. So on this particular box, and it's a little hard to make out because the chart is kind of drawn over the top of the picture, proving that developers shouldn't do UX design. But the old number they had on their benchmark there was in plain text, 8.4 million requests a second. 5 is hitting 11.8 million, which is a 40% bump in improvement. So again, from a throughput and a perspective angle, you should move to .NET 5 straight away, just to really reduce, better performance, better request time, less memory, all sorts of things. The Fortunes platform, which is that middle one there, went from 340,000 requests a second up to 421. 23% improvement in productivity, and all you've got to do is recompile for .NET 5. Kind of cool. Request times, response times, latencies have improved. Time to first request a little slower in a couple of them, but we're talking about, what's that, 7 milliseconds on one of them, 9 on another, and I think for a first request response, that's probably okay. Just go nuts, right? Make the conversion, have fun with it. What else do you need to know? You should probably kick the tires on Blazor. Microsoft's going to be pushing this a lot. I'm not saying adopt it. I'm saying have a look at what it does, how it might fit for you. Have a look at maybe the mobile bindings. There's just search for that. You'll find it. Breaking changes. IE11's going away. So is support for it. There are a few obsoleted APIs. Having had a look at what they are, there's nothing that should affect most people. They're fairly minor in nature. Signaler will use message pack 2 for the format instead of 1. If that impacts you, generally it shouldn't. Most people don't really think about the internal formatting and they just use what they use. Beyond that, not too much. So there's really a low risk from an adoption perspective, which leads us to the third thing that we should cover off quickly, which is EF Core. And again, what should we expect? Probably performance. But also there's a few other nice things that have turned up in here that have been coming for a while. The first is that many-to-many relationships can now be done without needing a class in your domain models or anything else to actually represent the join table. So happy about that. Hate those join tables. So that's really good. Save points or nested transactions have turned up, and then there's this thing called query splitting as well, which we'll cover in a second. So the many-to-manys mean that you can have a DB context that looks something like this with a few properties, and as you can see, posts to tags there is many-to-many. There is no posts tags DB set. When we generate this, if we do a migration, you'll see it generates the post flight table, it generates the tag table, and then it generates the join table for you. Puts all the indexing in there. Job done, happy days. Kill those join tables, murder them in their sleep. Get rid of them. Save points, again, fairly straightforward, nested transactions kind of approach. So you create a transaction in your context, you add a save point, give it a name, and if you need to roll back to that point, you can. Where this becomes useful is things like bulk operations, where you're doing maybe reading in a large amount of data, and you want to continue processing, but just drop out potentially every now and then when there's a record that doesn't parse correctly or doesn't go in the database correctly because of primary key problem or something like that. And you can continue processing everything else, or at least run through everything else spot all the errors, capture them all, and then abort, depending on what your business rules are. So that's really nice. Nice little benefit of moving to that. And then there's query splitting. So this one's a little interesting. The idea here is that in your DB context, you're doing, as you can see, context.artist, you do an include, then an include. That basically does multiple queries, as you would expect, as inner joins, left with a sub-select and then another one and yada, yada, yada. That one big query runs in a big chunky thing. When you do query splitting, you can now take that query and turn it into 3 separate queries, have them execute in parallel, and then do some aggregation more on the client side. So here the idea would be in the context.artist as split query, and then you do your includes. What that will generate under the hood is firstly your select of the artist data, then doing the query on the album, and then doing the query on the tags or whatever else it was underneath there. But by doing that, we're not doing a whole lot of left joins, inner joins, whatever else that the query thing's going to do in terms of its optimization. So the SQL becomes simpler, and then the SQL Server can actually handle that as a simpler query plan as well, which reduces resources and lets you do sort of things. And yes, you can do Cartesian explosion, and yes, it can get horrible if you do things badly, Lord Teaspoon, but like all tools, you can use them well and you can use them poorly. So with all these things, you've got to do anything with performance. Just pay attention to how things are optimized as you need to get the performance you want. Don't just apply a split query to everything because you've got a new hammer in your toolbox. A few other things that have come through in EF Core, filters on the includes. So when you do the includes, you can basically embed that where clause. You can do order by descending and do a take 5 in there, as you can see, which is kind of nice. So you can play around with these things rather than having to bulk grab everything. That's handy in some respects. Yes, concurrency problems with split query, Lord Teaspoon, are genuinely there. It's mentioned in the docs as well on the page, so they're aware of it. That's fine. And no tracking queries. One of the things here that this one's useful for, this perform identity resolution, is if you did this query without identity resolution, all the posts would create new instances of the blog object each time because it's a no tracking query. So each post would have its own instance, which means more memory and a little bit more CPU while it's spinning things up. Identity resolution keeps that to a single blog instance object because they might all reference the same blog ID. But that's going to come at a little bit of a different cost because it has to actually check what it's loaded and check the key exists before it instantiates. And so it's a little more CPU, a little less memory. Again, trade-offs in terms of how you want to do some of these queries. Worth having a look at, though, and in certain scenarios will be potentially quite helpful, especially if you've got a large number of posts, because it'll keep the memory footprint on your web server or your backend server down. A few other improvements: table per type in the inheritance hierarchies, as you can see, the ability to exclude tables in migrations. It's not uncommon. It's not common, but it's not uncommon for code bases to have multiple contexts where one table appears in two different contexts. When you're doing a migration, it becomes a bit painful if you're trying to migrate the same table onto two contexts. So you can migrate it on one and exclude it from the second now, which is a nice little optimization for those scenarios. You can map tables to entities to tables and views. I have no idea why you would do this, though. Maybe someone who does weird SQL stuff and has bizarre rules in terms of access, or who knows what. I don't know. I just don't understand. But you can put your updates into a table and query out of a view. I don't know. Unless you've got your view joining other data all the time. And anyway, good luck with that. And then migrations, idempotent migrations have improved. I've run into this one myself, where you try and generate the migration file and then it gets handed to the SQL server. The SQL goes, hey, I can't handle this migration because the column you want to change doesn't yet exist, because it gets created halfway through the migration script, and then you've got another bit later on that's doing something with it. So now when that idempotent migration is generated, it will actually wrap exec calls at the appropriate spot, so that the query will parse within the SQL Server, and when it runs, it generates the columns that you need for later on and handles that all quite nicely. So what do you need to know as a developer on this one? Fairly simple. It's got some good improvements in there. Obviously, the many-to-many is really nice. The query splitting, again, just make sure you test your performance improvements. Beyond that, there are a couple of little breaking changes. Again, they're really minor and unlikely to impact many people. Not like we had with .NET, with the last release of EF Core and the 3.x series, where you had that client-side evaluation. There's nothing to that extent sitting around. And it handles the nullable types slightly better with the nullable annotations in the code bases now. Still a fair bit to go in terms of EF Core itself, but it's getting better. So that's pretty much it. That's the quick run through. The short version, because for a little time. Francis, you're asking if would mapping entities to the table and view thing, I assume, be handy for CQRS architecture? Not really, because you're not necessarily doing the same entity that you update with as you query with. If you're doing CQRS, you probably want to have two separate views of what's going on. And you're trying to treat your queries more as DTOs rather than entities that you're updating into a domain storage. Might be helpful. I don't think so, or at least limited. So in wrap up, .NET 5 keeps getting better. You should probably move to it, because I can't see any real reasons you shouldn't delay upgrading, especially given all the performance and memory improvements that are continuing to be invested into the framework. You get to take advantage of C#9 improvements. You can do that now, obviously, and target the older runtimes. And yeah, okay, so Andrew says not being an LTS release might be a reason not to do it. If that's your organizational approach, enjoy that. But apart from that, are there any other questions? We should just check through the list. So I've been trying to keep up as we've been going, but I might have missed quite a bunch. So James, were there any more that have popped up?
Let me have a quick look through, but I didn't see any as we went.
If there are, just quickly pop them back into chat. I think how long we taken to get in the habit. I'm scrolling back through the list. Does that mean we can ignore this method is not being used? Oh, that would have been on app trimming. Yeah, no, fix your code. Aaron wants to know what the VB.NET improvements are. What?
Yeah, Aaron, it's going to be faster for VB.NET. All right. Any other important questions?
VB.NET improvement. Correct. All right. I think I've just talked far too fast and flooded everyone with more information. Beautiful.
Right. That was a good run.
All right. In that case, you know what we should do, James?
Maybe have a competition.
I suppose we could. Shall we do that? Yes. Yes. F#5 is part of it. I didn't do anything about F#5 because I'll admit I don't really know F#, and I don't know what's a good improvement worth talking about and what's not. Yeah.
Fair enough. Well, actually, before we do the competition, maybe we'll say that we're always looking for volunteers for the talks. So hit us up, send us a message on Meetup or Twitter or whatever. If you'd like to speak. So we've got a speaker for next month, but there's one spot, and this is, I think, the last for the year, because the December one is convenient. Yeah, not the time anyone's going to be tuning in.
In lockdown,
unless,
and we're going,
unless we're all stuck.
We need to do something.
Yeah, if that happens, we'll consider it, but let's hope not. So at this point, there's one spot left for the last speaker for the year. So if your goals are doing a talk this year at alt.net, which they should well be, then this is your big chance. So
Q Sharp improvements, I have no idea. They haven't talked about the quantum side of things at all, so I would suggest not, other than it's faster.
Yes. And there's also, as Aaron says, the suggest a topic box on Twitch too, which is a good point. But even better than suggesting a topic is presenting. All right, so to the questions. So if you have one organization and you're following Apollo's recommendations, this is on the first talk, how many graphs should you have? This is a maths question. I said no maths question, but this one is.
The HSC exam for that one's already been done. Why do we have to ask something so hard? Suds got in first by a couple of milliseconds. Look at everyone trying to. Oh,
close, but it was Suds. All right, send me a message.
It's actually faster to hit one and enter on the keyboard than it is to type O-N-E. That's why you lost.
You can see O-N-E was like a few seconds behind.
James's audio is out of sync.
Oh, really?
Wow. Okay. James, you move your mouth and I'll actually just say words on your behalf and we can do bad lip syncing.
Oh, sorry, everyone. I promise you the sound's working at my end.
It works on my machine.
Yeah, it works on my machine. Sorry, guys. It's probably just me. All right, so the second question, I hope the lag doesn't make it too tricky. Maybe actually we've got jitter here that gives some people an advantage for the competition. Ooh, need a low latency connection. All right, so the next one is on Richard's talk, as expected. So what's app trimming? And keep it short, but not as short as the answer to the first question.
Dun, 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 dun. Tree shaking, not tree shaking. Yes, I'm going with Lord Teaspoon's answer.
No,
tree shaking is close enough as well, but not quite as close. And tree shaking on steroids. Depends where they've been injecting them. Same as no, Francis. No. Lord Teaspoon said no. He won last month. Gareth wins it then. Or Garether.
All right.
Garether Hughes.
Okay, that sounds good. Here we go. So send me your email address, please, those winners on Meetup, and I'll forward you through your...
on Twitch. Unless you want to get spammed.
Yeah, probably better not to. All right. Have we got anything else, Richard?
No, I'm hungry. I haven't eaten since I downed half a bag of chips before coming on here. But you'll be glad to know, salt and vinegar, baby.
So, very good. Smiths are better, though. Got that. Anyway, so
that's how I maintain my figure.
All right. If there's no last questions or anything else, I think we'll bring the session to the close. And remember, we've got one more for the year. So come on, the volunteers, and send us a message.
And a big thank you to Anton again for presenting. Good job, Anton. Nice work, buddy. My noise cancelling is probably on. You probably can't hear me clapping, but you know.
Thanks very much, everyone.
All right, crew. Thanks for joining us on the Twitches, everyone. We will see you next month. Go home and have dinner, unless you're already there.